this video, we begin to tackle the vast topic of object-oriented programming. You can't get very far with C# until you understand both the philosophy and the practice of using classes and methods and fields within your application. And while we've been using classes and methods up to this point, I've always watered down the explanation of what those were by simply saying that classes were a way of organizing your methods into logical containers. Now, I did warn you when I said that I was oversimplifying that idea, and so today I want to more fully expound on those ideas. So object-oriented programming is a style of programming that when it was originally conceived, it sought to balance out what was going on in software development at that time. It sought to simplify the process of conceptualizing and coding a solution to a problem. Now I'm going to save you from a long history lesson here. Although reading about how these ideas evolved would probably be pretty useful and insightful, it always is helpful to understand how we got here. But when writing applications, it's helpful to think about how objects interact with each other in the real world. For example, consider the simple interaction of a person, a pencil, and a sheet of paper. The person grabs a pencil and a sheet of paper and starts to write on it. The pencil can do a couple of things. It can write, it can erase. There are other interesting things about the pencil. Its color, its length, it's the type of lead that it has in it. These are its qualities that potentially modify how it can write or how it can erase. Likewise, a person can do many things. He can jump, he can walk, he can write. And there are many qualities about each person that differentiate one person from the other. For example, hair color, height, IQ, first name, social security number, and so on. If you begin to think of your code the way that you think about objects in the real world, sometimes it becomes easy to organize the code and give responsibilities to code in a certain way. You can also represent interactions between code, much more easy when you think about them as objects. So, thinking about an object that we've been using up to this point, the console window as an example. The system.console class represents a console window in the real world, in the computer world. What can we do with the console window? Well, we can ask it to print a message, to retrieve information from the user. We can ask it to beep. We've seen it do all of those things. These were the methods of the console window. But there were also qualities of the console window. We changed its foreground color, its text color. We could also figure out how to change its background color. We could figure out how to change its size or its dimensions on the screen. So these qualities, which for now I'm going to call fields, can be read and can be set in our code to affect how it goes about doing its work, right? Okay. So when you think about object-oriented programming, whenever I've read about it, I often see the example of an automobile in order to explain real-world object-oriented programming. So think about a car, an automobile. There are things that describe each individual automobile. And I'm going to resist using the word properties for one moment. Let's use the word field, okay? So fields can include, for an automobile, things like the make or manufacturer, the year it was built, model, the number of miles it currently has, its VIN number, VIN, or vendor information number, I believe, its color, and so on. It also has operations such as ignition or start, accelerate or decelerate, turn signal, and so on. And I have to admit, my dad is great with cars. He can fix cars. I know absolutely nothing about cars. However, I can operate a car rather efficiently, even without understanding all the individual components of the engine, of the drive shaft, of the electronic components, and so on. All those details of how the car operates are hidden to me. The car is a black box, meaning that I don't have to know how it works internally, its internal operation. I can still make it work because I understand the interfaces, the steering wheel, the pedals, the turn signal, and so on. A more object-oriented way of saying that is that the car's implementation details are encapsulated behind a public interface. You're like, oh, what? What did you just say? Well, let's come back to that. Let's not get too wrapped up in that for the moment. Basically, what I'm trying to say is that almost all that I have to know from a technical perspective is how to use the steering wheel, how to use the pedals, how to use the turn signals, as well as a few rules of the road, right? But when I use those, there's hundreds, if not thousands, of little things that are going on under the hood that I don't need to know about at all. It's an amazing piece of craftsmanship, and this is exactly in the spirit of object-oriented programming. You should strive to write code that hides its private implementation details behind an easy-to-use public interface. So let's do this as an example. Let's write an automobile class, an auto class. And hopefully we'll use this as a concrete example to illustrate some of these abstract ideas that we've just been talking about. And we'll build on these today and throughout the days to come. All right, so here you can see I have a new project called Understanding OO, completely empty. The first thing that I'm going to do is I'm going to right-click in the Solution Explorer and select Add a Class. I could select New Item and find the class, but I'm just going to go right here to Class. And I'm going to make sure Class is selected in the Add New Item dialog, and then I'm going to type in just Auto, okay, and then click Add. All right, so you can see now I have an empty class called Auto. So I'm going to start defining some qualities or characteristics or fields of information that define something unique about each individual automobile. Okay, so let's start by defining things like its make and its model. So public string make, public string model. Let's give it a public int here, public color string color, public int miles, public int what's its current speed on the speedometer, right? We could do that. All right, so those are things that describe the state of the automobile as it is right now. Certainly we could change the color, the miles will increase, the speed will accelerate and decelerate, but for right now that can describe the state of a given automobile. We could add additional things, but let's just stop right there. We'll just kind of seal it off right here and move on. But there's also things that we can do with the car. We can turn it on. Maybe that's not a good example, but we can accelerate and decelerate. That's probably a good example. So let's do this. We're creating a method called accelerate. And when we call this method, we want the car to speed up. So we're going to increase the speed using that incrementer operator that we talked about yesterday, right? And then, just for reporting purposes, we're going to display the current speed. What is the current speed? Now, if you can't accelerate, you also need to decelerate. Unless you have a Toyota. Just kidding. Don't sue us, Toyota. All right. Cancel that red line. All right. There we go. Now we have a car, right? We have a car, an automobile. Well, not exactly. At this point, all we have is a blueprint for a car. This is the design of the car. We want to potentially produce hundreds, thousands, millions of cars. So there's an important distinction between writing a class or a blueprint and creating an instance of that class, like an assembly line where a car is actually pumped out and it can get on the road and do something, okay? And the same thing is true within our applications. We've only created the blueprint. We haven't actually run it through the factory and created a new instance of that blueprint, okay? So let's do that now. We're going to go to our program.cs file. Up to this point, this is the only place we've been working in code, but now we're working with this second file. Did you notice, haven't really talked about this too much yet, but the tabs pop up at the top. All right, so what I want to do is create a new instance of this automobile. And how do I do that? Well, remember that new keyword that we've always seen but didn't really know what it did? I think I even yesterday said think of it as a factory. Well, in this case, it kind of makes sense as a factory, right? Here we are creating a new instance of the automobile class called car. So now this is one instance of a car. We've pumped out our first car from the assembly line, and so we can start saying things about the car. What's its current speed is going to be 0, and its current make will be an Oldsmobile. Equals 1988. Car.color equals silver. Okay, so now we know a little bit more about our car. It is an Oldsmobile Cutlass Supreme from 1988, color silver. Probably should assign some miles to it too here. My car.miles. Now notice when I was typing in that IntelliSense knew about my car class, and it gives me, you know, all of the the fields that I've defined, as well as these methods that I've defined. And it tells me a little bit about them. For example, miles is an integer. Okay, neat. Another reason why we can rely on IntelliSense to help us write our code. Let's give 50,000 miles. Low mileage. All right, so now what if that's how I'm setting the values of my car? How about if I need to read those back out? What can I do? Well, again, I'm going to use that dot notation that I used to access the members of my class. In this case, the members of my car object, by using the dot notation and then typing in the field name. Let's do the same thing to actually access those methods to get their current values out. So I'm going to do my car.make plus, and then I'm going to add an empty character there, just 2 quotes with nothing in the middle, is just an empty space, so that they don't come up right against each other. And we'll go model here. Okay, so sweet, let's do this. Let's run the application. Well, one more thing, we have to always do this, right? And it doesn't like the comma 50,000. Sorry, I formatted the number there. All right, so you can see we printed it to screen. So what do we really do there? We accessed a class or an instance of our class is called an object. We accessed its properties by setting values to those fields, rather, and then retrieving those values from those fields. Okay, so next up, let's actually use the methods that we defined. So here we go. My car.accelerate. My car.accelerate. We'll just keep accelerating. My car is a fast car. Whoops. And then we'll decelerate a little bit. All right, and then let's see what we come up with. Let's run the application. All right, so you can see that as we speed up, we're going from speed 1 mile an hour, 2 miles an hour, 3 miles an hour, and then we are slowing down a little bit. Okay, and that was all accomplished by accessing, the current speed. So now let's do this. One more neat little thing here. All right, so we're going to then write out my current speed. And run the application again. All right, so it's 2. And you can see that these methods were used in conjunction with the current values that were stored within this class in order to modify how the method actually worked or what it accomplished. Okay, so let's back up and start all over again. Hopefully this is a working model for now, and we're going to expand on this idea. If it didn't make sense completely, don't worry, we'll come back to it. Just want to recap everything that we've just said. So for the last 2 days, we used a working definition of what a class is, calling it an organizational container for our methods. And I promised that we would expand on that definition. So now I want you to start thinking about classes in a different way. Classes are like blueprints to create new instances of objects. So you can think of the word new as a factory that creates a new instance of an object out of thin air according to the design of the blueprint, the class. Classes are a basic building block of object-oriented programming where you abstract the important parts of a given entity, like an automobile, into code by defining its attributes or its states, as well as defining the actions it can perform. So a more object-oriented way of saying what I just said and demonstrating what we just did is that you can write code to create to define a class's fields and its methods. Then you write code to create instances of those classes called objects. So objects are different than classes. And then also, like we did in the program.cs, you write code to make those objects interact with each other, similar to how they would interact in the real world. If not physically, then at least conceptually. Okay, so I know I dropped a lot of information on you. In the next few videos, we're going to fill in the details about fields and methods and visibility and more. And we're going to continue to build on the notions that we started talking about encapsulation and about instantiation of a class into an object and so forth. So stick with it. Hopefully this didn't blow you away. It's going to get a lot harder though, I'm sorry. And I'll see you in the next video.